Hello everyone, this is Dr. Speranza and welcome to my YouTube channel. And if you happen to be here for the first time, I am a math teacher who uploads math videos in my YouTube channel from algebra to college level calculus. And for today it's going to be a little bit special because we're going to be sitting in my classroom here in Barstow Community College, and I'm going to show you how to learn and how to solve problems on limit of a function. So does the limit exist? That's the problem that we're going to answer today. Now, limit of this function as x approaches 3. So how are we going to solve problems like this if it will exist? We're not solving it yet because right now we're not seeing the graph, right? So if we're not going to be seeing a graph, how are we going to solve it using algebra or using mathematical process? Do you have any idea how to solve this limit of a function as x approaches 3? Let's modify the problem. This is now your f of x, right? What is f of 0? Can you solve it this time?
Yeah.
How are you going to solve this?
Plug in 0.
Plug it in. Plug in 0 to the function. So if you plug in 0 to the function, can you do it mentally? What do you think is the answer? Negative 1 or positive 1?
Positive 1.
Turn to 0. Turn to 0. Yes. Turn to 0. Yes. So f of 0 is just equal to 1 because you're just basically substituting the values of x to your function so that you can find the value of y. So this one is 0 and 1. So at 0 and 1, your function exists because it's just f of x. But what about this? Now, from this, we solved it, right? Same function, but this time, the notation is a little bit different. This is still the limit of the function, which is f of x. What would be your f of x? This is supposed to be f of x. What would be the limit of the f of x as x approaches 0? How do you think we're going to solve this? It's also just substitution method. You're just going to substitute the values of 0 to x and see if it will exist. So if you plug in 0 right here, 0 right here, 0 right here, will you have a value that is defined, an actual number? Yes, because we just solved it, f of 0. So basically, finding or solving a limit algebraically is as simple as the substitution method. Students are just a little bit intimidated because of the notation. It's too foreign to them. Because this is the first time students are seeing this particular notation or symbol in a calculus class. But if they know what it means, it's actually really simple and pretty basic. So you're just substituting it to the values of the function. So, knowing that this is your f of x, can you solve this now? If f of x is x squared minus 5 and you are supposed to find the limit of f of x as x approaches 0, can you solve this now? Yes. By substitution, you'll be able to solve it. And this is the value of the limit. Can you please solve this as x approaches 0? Okay, because you have 0 squared plus 3 times 0 all over 3 times 0, which gives you this turns to 0, this turns to 0, and this turns to 0. And it's 0 over 0. Now, in calculus, it's important that you write your answer something like this, because this is a special case of a rational expression. In calculus, we call it indeterminate. Every time you see a fraction that is 0 over 0, it is considered as an indeterminate expression or rational expression, and we're going to go through that later on. I'm going to show you why it's important to know that a function is indeterminate in solving a calculus problem. Now, we know it's 0 over 0, and we know that if the denominator is 0, it's undefined, right? So essentially, this might not exist. However, look at the numerator of the function f of x. Can we factor it out? Yes. If we factor it out, what factoring technique are we going to use to factor the numerator? Greatest common factor, or GCF. And what is the GCF of your numerator?
3.
Just 3?
3x.
3x. That's why it's called greatest common factor. If it's just common factor, then 3 would qualify. But we want the greatest common factor. And if we undo the distributive property, what's left inside?
X plus 1.
X plus 1. All over 3x. Is this function the same as this function? Yes or no? Do they have the same value? Yes, because we just modified it into its factored form. But by modifying to its factored form, what do you notice? Can we simplify the rational equation?
Yes.
Yes, because now we can cancel it. So by canceling it, the f of x is now x plus 1. So, if we're going to solve the limit of the function now with this modified version of your f of x, do you have an answer in your problem now?
Yeah.
Yes, and what is it?
1.
1. Because using, or when your f of x is in algebraic form, you're not seeing the actual graph. And when you're not seeing the actual graph, you need to perform a special mathematical process or procedure so that you can verify that it does exist. Because substitution is your first line of defense. When substitution is not working, maybe you need another technique. And this is why solving limits given an equation or an f of x in algebraic form is a little bit more complex, because now we are moving from solving limits graphically. Now we're moving to the second level of answering a limit, which is analytically, which is going to be a little bit more challenging. Okay, and if you want to know more about solving problems involving limits, just click on this button right here and it will give you more examples and more topics on how to solve limits algebraically, graphically, and analytically. The first line of defense is substitution. All algebra students can substitute. You're now a calculus student, so you can substitute, right? Okay, give me the values of the 3 limits using the technique that you already know. Sige. Alright, were you able to solve the limit? For 1, 2, and 3? Okay, what about number 1? What is the limit of the function 2x plus 3 as x approaches 2? 7. So by substitution, you know it exists and it's equal to 7. What about 2x squared plus 3 as x approaches to 2?
11.
It is 11. And what about this rational function 2x plus 3 all over x minus 2 as x approaches to 2?
Undefined.
Undefined, because what is the numerator here when you substitute the value of 2?
7.
What did you get?
The numerator is 7 over 0.
7 over 0. So if the limit is 7 over 0, is this considered indeterminate? Yes or no?
Yeah, no.
No. Indeterminate is 0 over 0. So that is the special case that I want you to remember. 0 over 0 is indeterminate. So if this is not indeterminate, what is this then?
Undefined.
Yes, undefined. Alright, so there are 2 types of rational expressions with 0 as a denominator, indeterminate and undefined. This one is undefined because the denominator is 0. So, logically, the limit does not exist for this one, right? Because it's undefined. So now you solved it using substitution, which is pretty basic and pretty simple, and that is how you solve it. Now, what about this one? If you have limit of 2x squared plus x minus 3 all over x minus 1 as x approaches 1, can you please solve this limit? Alright, were you able to solve it? What is the numerator when you substitute the value of 1? What is the value of your numerator?
0.
0, and the denominator?
0.
So it's also 0 over 0. So this is indeterminate, right? Using the substitution method. However, this is a factorable quadratic equation. if you know how to factor this out, you can simplify it and modify it, and it will look like this. And when you factor it out, what happens to your function? Can you simplify it?
Yes.
Now you have the limit of 2x plus 3 as x approaches 1. So, when you factored it out, did your limit exist in this particular method? Yes. And what is it equal to? 5. Because it does exist. That's why in calculus, you need to really know your algebra fundamentals. And the most important algebra skill that you need to master, not just know, but master, is factoring. And there's a lot of factoring skills or factoring techniques in algebra that you need to master so that you won't get frustrated in some problems in calculus. Because you're not only using factoring in solving for the limits, you're also using this in derivatives, integration, proving identities, and a lot more. So factoring is extremely important because by factoring, you'll be able to solve a certain problems like this. Now, I'm not going to ask you to solve it, but see this? See this? See this? All of these are functions that you will encounter in calculus. And the reason why calculus is difficult for most students, not because of the class itself, but because they don't know algebra. Because without this, without this, without that, and you're asked to simplify problems like this in algebra, all of them are just algebra problems. And it became calculus because of this symbol. But if you know your algebra, calculus would come a lot easier. Because we know that that exists, that exists, that exists using calculus. The question now is, how are you going to prove that it exists using a mathematical process? We're going to be solving limits using technology this time. So before we dive in to the algebra techniques and factoring techniques that all of you should know by now, which I know you don't know, we're going to cheat. We're going to cheat with our calculator. And the reason why you need to know how to use your calculators, because in mathematics, it's not all about knowing how to do intricate process by hand. Sometimes we need technology. That's why we have cell phones. That's why we have all these technologies right now. It's the product of the tedious process that we can simplify using this. And that's what we're going to do. We're going to be using our TI-84 to solve this limit that we know exists. How are we going to make it existing? We're going to solve this first. This is our f of x, right? Without using the calculator, can you solve for f of 0 without using a calculator and pen and paper for f of x? Just look at it. Can you solve it? What is f of 0 if f of x is this function?
Negative 5.
Oh, good job. You can do mental math. What about f of 1? Can you still do mental math? 0 over 1?
Over 2.
Over 2,
0 over 2? So it's 0. Okay, good job. Mental math.
I know.
No?
Absolutely.
All right, we'll use this. Okay, how do we use technology to solve for that function? Ready to learn some calculus or calculator magic? This y function right here is what we're going to use, which means your calculator, you can instruct your calculator to compute that function at any given values of y. So all you have to do is to plug it in. So y sub 1 is going to be the function that we're working on. 3 So this is how you can instruct your calculator to do the calculation for you. Go to second function, Windows. Second function, Windows, go down, and independent, go to ask instead of automatic. Because if it's automatic, your calculator will produce the numbers for you. But we don't want that. We want to produce our own numbers. So now that it's ask, go to second function, graph. And you will see a table of values. Do you see a table of values like this? Yours is supposed to be empty. Is it empty? 2/3. So at x, 2/3, your y value is negative 3.889. There. That is the value of y. So this is how you use your calculator so that your calculator can compute your ugly looking function and give you the values of y automatically. Now, are you seeing it visually in your head what is happening in your calculator? It's giving you the values of y without seeing the graph. Can you please hit the graph function? What does it look like? There. It looks like that. This is the graph of the function, and what the calculator can do is that at any given values of x, it will give you the corresponding values of y. At any given time and at any number or real number. It could be positive, it could be negative, it could be a fraction, it could be in decimal. Clear? Okay, because we're going to be using that in solving our limit function. If we're going to find the values of the limit right here, at x equal to 0, did you plug this into the calculator correctly? Can we plug it in correctly this time? Because we will need it. What about at -1? What does it give you?
Error. So undefined.
Or does not.
We don't know yet, because what you're doing with your calculator is just finding the value of f of -1. That's why it's undefined, because you're substituting it. But what we can do is approximate the values of your y when x is approaching that number. So how are we going to make it work for our calculator? So using this, we're just going to focus on this because right now it's still an error, right? Because we're still not applying the limit in your calculator. Now let's go back to the graphing method. If in the graphing method, we're looking for f of x as x approaches 2, what are we doing to solve for that limit? We go at x equal to 2, and we look coming from here, the values of y is approaching this, and coming from here, the values of y is approaching this number, right? So this one is DNE graphically. But if we're going to find, let's say, limit of f of x as x approaches -1. Is it existing? Yes. -1, it's somewhere at +1, right? Because coming from here, it's the same. Coming from here, it's the same. That's what we're going to do in this problem. How? We're going to draw a little bit of visual. 0 and -1. Approaching this value and this value, but we need to avoid -1 because -1 is probably an open circle. So at exactly x equal to -1, it's undefined because it's an open circle in this function. But what we can do is approximate the value of that function from the left and from the right to see what this value is. Now, how are we going to do that? Let's use a number between -1 and 0. What is a number between -1 and 0? -0.5. So push -0.5. Is it giving you a value?
Mm-hmm.
Now, we need to move closer to -1. Can we pick another number that is closer to -1 but not -1?
-0.9.
-0.7. Negative 0.9? Yes. Okay, push it. Is it the same value or a different value now? A different value. Now move a little bit closer. Can we do that in your calculator? What value would that be? Negative 0.999. Let's do 3 nines. What does it give you? It's approximately equal to negative point.
4.00.
Negative 0.4.
No, negative 4.004.
Negative
4.004.
It's been a long day. All right. Now, we're not finished yet because we need to make sure that it's also going to be the same number or y value from the other direction. So we need to approximate again. So this one is negative 2, right? What is between negative 2 and negative 1? Negative 1.5. Okay, let's start with negative 1.5 so we can visualize it better. Is it negative 4?
No.
Let's move closer. What's closer to negative 1 but not negative 1 from the left? Negative 1.1? Alright, use negative 1.1. Is it closer? Is it getting closer and closer to negative 4? Now move a little bit closer then. What number are you going to use?
1.001.
Negative 1.001? Okay, do that. What is the value now?
Negative 3.996.
So, what do you notice about the values of y coming from the positive side and coming from the negative side? Is it approaching a same value?
Yes.
And what do you think is the approximated value of the function?
Negative 4.
Negative 4. So if we're going to solve this, the limit of f of x, which is this, as x approaches negative 1, is actually negative 4. And it exists. But when you hit 4, when you hit negative 1, what does it give you? Error, because it's actually a hole. And your calculator, when you graph it, can you please push graph? What does the graph look like at x equal to negative 1? A parabola, like this?
Yes.
So at x equal to negative 1, there should be a hole there. But your calculator is not showing you a hole, unfortunately. So what we're doing is we're just approximating, but notice that it is approaching a certain value of y, which is negative 4. So do you understanding how to use technology and why? And you're not going to be able to understand and appreciate the calculator had we not started with calculus using a graph, right? Because now you're understanding why technology can help. And if you happen to like my video, please like, share, and subscribe to my channel. And today we worked on the limit of a function, and hopefully you'll be able to learn more on my YouTube channel. And again, thank you so much, and see you again in my next workshop. Students scored above 90 points on this statistics test. So 90 points is somewhere here, above it.